Alright, we're going to do a quick one on ionic bonding. What types of atoms combine to form an ionic bond? Well, you should know that we have metals and we have nonmetals. And when they bond together, they form something that is an ionic bond. If you remember, metals lose their electrons, so they become positive and they turn into cations. And nonmetals gain electrons, and hence they gain a negative charge, and they turn into anions. Okay, so it's always metals. Well, for purposes of right now, it's metals and nonmetals. Okay, so let's give some examples of ionic compounds. Well, there are lots that you know about, but the most common is NaCl, sodium chloride. So the sodium is a metal, the chlorine is a nonmetal. So you could just go down your periodic table and keep doing that. Rubidium chloride. You could also do things like sodium, and instead of using chlorine, use fluorine. So it becomes sodium fluoride or potassium fluoride or rubidium fluoride. All right. You could also do other things, and you might do something like MgCl2, but you probably wouldn't realize that there was a 2 out here because you don't know that yet. That's okay. Don't worry about it. If you said MgCl, that's great. We'll take it. Because all you need to know is that it's a positive and a negative, a metal and a nonmetal. All right. In an ionic bond, the electrons are remember that the octet rule. Atoms tend to gain or lose electrons. We're not talking about sharing. Atoms tend to gain or lose electrons, so we're talking about electrons are gained by one atom and lost by the other to turn them into ions. So if they are ions, what holds ions together? Well, magnetic charges. One is positive, one is negative, opposites attract. Okay. So why are ionic compounds such poor conductors in solid form? Well, it's because if I have sodium, it's lost an electron, and chlorine has gained that electron. That electron now belongs to chlorine. It does not want to go anywhere. So as a result, when you have something in a solid form, the electrons are stuck with the chlorines, and the chlorines are in a fixed position, if you remember the crystal lattice, which we'll talk about in a minute. So the electrons can't go anywhere, and electricity is electrons, so the electrons cannot move through an ionic substance. However, when they're dissolved in water, here you have a bucket of water, and you have sodium ions dissolved in it, and chlorine ions dissolved in it. Sodium and chlorine break up into pieces. So as a result, when you put electricity into here, well, the chlorine, if you're putting electricity in, if you're putting negatives in, well, that attracts the positive charges. So the positive charges are going to go here, so they're going to move. So once they're in water and they're dissolved, the positive and negative ions can move around. Not the electrons, but the ions themselves. All right, 4 properties of ionic compounds. Well, one, we said they're brittle. Right? We said they were solid at room temperature. We said that they had very high melting points. We said that they dissolved in water. Most of them. Not all, but most of them dissolve in water. We said that they are poor conductors if they are solid. And they're excellent conductors if dissolved, or if they've been heated up to the point where they are a liquid, if they're in their molten form, which has to be extremely hot, by the way. All right, what's a crystal lattice? If you remember, what we talked about was something that kind of looked like this. And at every intersection, this might be sodium, and this might be chlorine, and then this might be sodium, and then this might be chlorine, and they all line up because the positives and negatives are attracting, and so you'd get a sodium here, but it would be surrounded on all sides by chlorine. There'd be another one up here, right? And frankly, there'd be another one in front of it and behind it, and so this makes a crystal. Right? So that's where the crystal comes from. All right, that's it. If you have questions, see me in class, and have a great day. Bye.